Here we go. So this one technically doesn't have a wrong answer. You just have data to form your opinion, okay? So we've got 2 colleges here, and they give you information about their mean salaries of graduates, so what the graduates are being paid, and the standard deviation of what they're paid. So when we're thinking about something like hatching, so I'm going to take a hatching here. That's a bad H. Let's try that again. Stop walking. H. There we go. What they're telling us is that our mean salary, our average, that middle, is $45,000. I'm just going to put K because I'm lazy. And it has a standard deviation of $1,000. So what that tells me is that most people, a majority, are between $44,000 and $46,000. So most people are in that little window, real close together. For Sluggington, they tell us our average, our mean, is 47. And the standard deviation is 6,000. So most people are between 41 and 53. So it's a much wider area. What you do from that is you form an opinion. There's not a wrong opinion to have. If you would like to do hatching because it's fairer, everybody's closer together, you're guaranteed to get 44, or you're most likely to get 44,000 at least, great. If you want to do Sluggington because you've got a higher chance of getting a higher salary, because most people are up to 53. You're also taking that gamble that you could get 41. So it's a wider spread, but it has higher options. Hatching is closer together, but it's kind of in the middle. You don't have a chance for as high of an option. So you get to form an opinion on there. There's not a wrong opinion. It's an opinion. Opinions are things that you can have. You just are choosing if you want to take the risk or if you would like to not take the risk and to go with the safe option. And that's your choice. Okay, so that's what that one's asking about. You have to have a reason. If you tell me most people are between 44 and 46 in hatching, and most people are between 41 and 53, you have used your mean and your standard deviation. Give me that range of values where people are, and you've used both data points. After that, it's tell me your thoughts. Form an opinion. Okay? Good question. Because it's been like August since we did standard deviation stuff.
Can we do
21? Let's look at 21. Let's see, where is 18, 19? That's a... Next. 20. 21. Ooh, that's a good one too. Like it. All right, so we are going to be matching the curves to the equations. Only problem is all of them start at 2. So they're all going through that y-intercept of 2. They all have that starting amount of 2. So really what we need to know is we need to know which ones are growth and which ones are decay, and which ones are growing faster and slower from looking at the picture. So, I'm just so that we can have ease of talking about, I'm going to number these. 1, 2, 3, and 4. Awesome. Thank you. What's up? What's up? It's like 100%. It looked like you were about to do like the Camp Rock. It was giving Camp Rock vibes. 100% Camp Rock vibes. Huh? What's up, bestie? What's up, bestie? Bruh. All right. So looking at these equations, Do we see any that are maybe growing, maybe decaying? What are we thinking? Go ahead, Amber. Number 4 is growing. I'm with you on that one. We can tell because we're looking at that growth factor. That guy that has the exponent. This is the piece we're really looking at. If it's bigger than 1, it's growing. So what other one up here is growing? 2. So this one's also growing. So on our graph, which 2 are growing? Yeah, just put that in my distance. C and D are our growth. So 2 and 4 are going to match with C and D. And we have to figure out which one's growing faster and which one's growing slower. So of 2 and 4, which one's growing faster? See the picture and which equation? 4. C is moving faster. It's going shrink way up fast. This one's growing, but is growing a lot slower. So C is growing really, really fast. And this equation is growing our fastest. So that's going to be C. D is also growth, but it's a slow growth. So that's going to be equation D. That looks like an O. Better. So then we do the same things with our decay. We want to know which one's decaying faster and which one's decaying slower. Go ahead, Amber. Yeah, one's going to be decaying slower. How can we tell that this one's slower? Because it has a higher number. It's closer to 1. The closer it is to 1, the less it's changing. Okay, so this one is our slower one. Slower decay. So which is it going to be, A or B? Which one's moving slower? A. Process of elimination gives us that 3 is B. It's also our faster decay, still going through 2. And all that jazz, okay? So we're looking at that growth factor. Always a good idea to double check your starting amount. All of these went through 2, but it could be that they don't. What's up, Red?
Why is 1 smaller? Slower.
Because it's closer to 1. This piece is closer to 1. If the growth factor is close to 1, it's barely changing. If it's farther from 1, so like this guy was slower and this guy was slower because these 2 are the closest to 1. If I put this as a decimal, it's 0.25. So this is closer to 1 than this one is. And this one's farther from 1 than this one is. So the 2 closer to 1 are the 2 slowest. Yes, sir. Number 4. That's on this page. Oh yeah, jump like a flea. This is very similar to our hop like a frog stuff that we did last semester. It's been a minute. It's those guys. I've got them up on my wall up there still. Up top. Behind the cabinets. Up yonder. So what we have is that fleas are excellent jumpers, and if a human could jump like a flea, they would be able to jump over the Sears Tower in Chicago. I know it's the Willis Tower now, but it's still the Sears Tower, and it shall be forevermore. Okay, so what we have is that fleas are about 0.1 inches long, and they jump 35 inches. So first thing we need to know is we want to know how much jump per inch. I want to find the ratio for the flea. And since I care about the jump, I want to know about that jump. I'm going to put the jump on the top of my fraction. So the information that I have is going to be the inches of jump per inches of flea. I care about the jump, so I want the jump on top. If I cared about like the speed, like we did ants versus cars and the hop like a frog, that one was all about weight. So I would put the weight per ant, weight per car. So what we have is, I know that the flea can jump 35 inches, and the flea itself is 0.1 inch. So what we can do is we can simplify this and say, all right, I've got a teeny tiny flea that jumps 35 inches. What if that flea was 1 inch high? What if I simplified that down and got this terrifyingly giant flea? How far would it jump? So what we're gonna do is we're gonna type that sucker into a calculator. And boop. I'm gonna say it's 35 over 0.1. And I would like them to simplify this. When it does that, it's gonna make our denominator 1, because that's way easier to work with. So 350 inches. So when we simplify this, it's 350 inches of jump per 1 inch of height. So I simplified it down. So for every 1 inch of height, they can jump 350. So what we're gonna do next is we're gonna look at our human, who's 5'11". And I wanna know how high he'd be able to jump if he could jump like a flea. What's your instinct on what to start with here? Yeah, I've got mixed units here. 5'11". That's 2 units. I don't want to do that. Let's get it all into one. And going into inches is probably easiest because 11 inches is a gross decimal. So let's find out how many inches tall Wesley is. How am I going to figure out how many inches tall he is? More specific. 5 times 12. 5 feet times 12 inches gives me 60 inches. How tall is Wesley then? Yeah, because that's just the 5 feet. He's still got the 11 inches on there. So we plus the 11. So he's a total of 71 inches. How can I figure out how high he'd be able to jump if he could jump like a flea? If every inch of height can jump 350 inches, what are we going to do with his 71 inches and the 350? Multiply them. So we're going to take our 71 times the 350 to find out he'd be able to jump 71 times 350. 25,850 inches. $24. Fixing. Thank you. I was just going, was it 25 or was it 24? I was about to pop back and double check, but I wrote it down right. Thank you. Keep me on it. Keep me honest. Keep me right. Call me on it when I forget things between page turns. So, does 24,850 inches tell us anything about if he can jump over that tower? What do I need to do? Convert it into what? Feet. How am I going to convert 24,000 inches into feet? Divide by 12. I'm going to come over here and I'm just going to hit divide 12. 2070.8. So he could jump 2,070 feet if he could jump like a flea. So remember, the claim is he'd be able to jump over the Willis Tower. Could he jump over the Willis Tower? Yeah, with like 600 feet to spare. So yes, it's true. He can jump way over it. He's a lot higher than that tower. About 600 feet to spare. Okay, so it's all about the unit conversions and building a ratio. So figure out what piece it is we're focusing on. Like we were focusing on the jump, so we put the jump on the top. If we were focusing on weight, we'd put the weight of something on the top. If we were focusing on speed, we put the speed on the top. So we're going to do a ratio with what I want, what I care about on the top. Okay? 1 and 2? 22. Okay, so we'll do 1, then 22. So give me a second. I think I have to erase one from yesterday. Oh, that's not what I meant. There we go. Yeah. It's one of those I've only erased when I needed to so that I can just upload it and have all my work for everybody's everything. There we go. So we've got this pattern here. I've just numbered them 1, 2, and 3 so it's easier to talk about. Okay, we're asked to find the number of tiles in the 65th figure. So what we're looking for is what is our pattern. I need a pattern because I don't want to have to draw this all the way out to 65. Ew, gross. So what we're going to look for is the things that change and the things that don't change. So let's start with what's something that we notice in all 3 shapes here that does not change? The 4. Those 4 pink squares, for you, they're super dark gray. Those 4 squares are there every time. Whatever is happening to the light blue piece, there's 4 squares on the outside each time. So whatever's happening to the middle, we add 4. What I'm going to do to make it easier to see what's going on is I'm actually going to cover up the pink one so we can just look at the middle. So I want to see if we can figure out the pattern between the number of our figure and what's happening in the middle here. So we're just looking at the light blue pieces. What's going on here? The squares. They're perfect squares. So when I try and make the 4th figure, so if I wanted to go make 4, that's the highlighter. Okay, I'll do that. How many are going to be in the 4th box here? 16. How do we know that? What did we do with the 4? By itself. We took and we did 4 times 4, because this is 3 times 3, and this is 2 times 2, and this is 1 times 1. So we're taking whatever our figure number is and squaring it. And then we add those 4 pink squares. So if I was really drawing the 4th figure, I'd then add my pink squares. That's a square. And that's a square. So we'd be able to figure out the 4th figure. 4th figure is not the one I care about, though. I want to know about the 65th figure. So what are we going to do with that 65? Plug it in. We're going to do 65 squared plus 4. And we're going to type that in the calculator. So we're going to go 65 squared plus 4 and get 4,229. Make sure you go back and read the question you were asked. Make sure we find the number of tiles in the 65th figure. It's not enough to just have the equation there. You gotta make sure you answer the question that's being asked. Okay? Any more questions on this one? Okie dokie. So the next one I heard was 22, which was, nope, 20, 22. Substrate year. So it's a very similar vibe to the flea one. What's up? Yeah, take the big glass. I care about how much substrate per gallon. We've got his fish tank, or his lizard tank. And so he's got substrate in the 30-gallon tank, and he buys a new 55-gallon tank, and he puts 5 kilograms in. So I want to figure out which one has more substrate. So if I care about the substrate, I'm going to put that on top. My 30-gallon tank, my small tank, I'm not going to call it small, gets 2.8 kilograms per gallon. Nope. Per 30 gallons. And my large tank gets 5 kilograms per 55 gallons. So what we're going to do is we're going to type both of these into the calculator and figure out exactly how many kilograms per gallon they get. So we're going to do 2.8 divided by 30. 2.8 over 30. And we get 0.093 repeating. Kilograms per gallon. When we do the 5 over 55, I would like it as a decimal, please. 1/11th, and we get 0.090909090909. .090. So which one has more kilograms per gallon? Which one is substratier? That tank. The small one. Because this one has more kilograms per gallon. This one's 090, this one's 093. So they're close. The lizard's probably going to be happy because I doubt they care that much about how much dirt is in their cage. But this one has more kilograms per gallon. It has more substrate for the space. So think of it like the hop like a frog or the jump like a flea. Whatever the piece is we're looking for, put that on the top. It's going to make it easier to do your comparisons. I care about the substrate, so I'm going to put the substrate on top. And then I can compare. So, yes, dear. 23. Do the next one. All right. Parabolas. So to start this out, we're going to go with identifying all of our points first, and then we'll start building forms. Okay, so where do we have roots on this picture?
0, 0, or -6, 0.
Yeah. 2, 0. And -6, 0. I 100% agree with that. How about the vertex? Where's our vertex here? -2, 8. It's this guy up here. How about our y-intercept? 0, 6. So there's identifying the points. When we're putting them into the forms, like we've got at least one of them over on the chart over there. So we have our y equals a x minus one of the roots, x minus the other root. So we know y equals whatever our a value is, which we don't know yet, x minus one of our roots is 2. And the other one of our roots is negative 6. To figure out what that a value is, we pick any point that's not the root and plug it in. So what's any point that's not one of the roots?
-4, 6.
-4, 6. Yeah, absolutely we can do that one. You can also pull the vertex, or you can use the y-intercept. Either one of those is fine too. But if we want to use -4, 6, totally fine. So my y value is 6. A, I don't know. My x value was -4 minus 2. My x value is -4 plus 6. That is 100% fine. Totally fine. And what we're going to do is simplify this. So we have 6 equals a times -4 minus 2 is -6. -4 plus 6 is +2. So we have 6 equals a times -12. So what does a equal? How do I get a by itself? Divide both sides. So we have 6 over -12, which is technically correct, but it's not the best math grammar. I should simplify that. What is 6 divided by -12? -1/2. So my a value for all of my forms is -1/2. Which means now I have enough to fill in my factor form and my vertex form. Y equals -1/2 x minus 2 x plus 6. It's the same piece we had down here. It's just now that I know what my a is, I fill that guy in. Identifying our roots and filling in factor form is probably gonna be the more important part of this question. Notice which equations we give you. Okay, so vertex form, which is, not on the reference page. So, factored form probably important. If it's not there, it's probably not on the final. Okay. Subtle. It's not on there. So. Okay, so we're filling this in, but it will probably not be on the final. Okay? So don't stress. Y equals a x minus h, so this is part of our vertex point, x minus -2 squared plus k. 8, that comes from our vertex point. The way we get from factor form to standard form is we're going to take this guy out and multiply him out. -1/2 times x minus 2 times x minus 6. So I'm gonna do my binomials first, the guys in the parentheses, to multiply it out. You can box it, you can distribute, whatever you do, we should wind up with x squared minus 2x minus 6x plus 12. Which I'm going to combine my like terms before I do my distribution. X squared minus 8x plus 12. And to get it into our standard form, we distribute that minus 1/2. So we're going to have our minus 1/2. Negative 1/2 times minus 8. Oh, that's x squared, sorry. Negative 1/2 times minus 8x gives us plus 4x. Negative 1/2 times positive 12 gives us minus 6. Oh, that's what went wonky. That is a positive 6. I'm like, my y-intercept does not match. That should be a negative 12. We should have wound up with positive 4x, negative 12. Give it a positive 6x. There we go. Sorry, I copied down the equation wrong. But then again, to remember, most important part of this piece is to be able to identify your roots and write it in factored form. Subtle. This is the one that's most important. I'm subtle. I'm being very, very sneaky right now, right? Super duper subtle, not giving anything away. Okay. Got about 10 minutes left. You guys want to pick one more, or you want to have the rest of the time to work? 14. I hear it. 14 is... writing a line. Point slope, or a point and a slope. So this equation is up there if you want to look at the slope formula. It's there. We didn't really use it. We did it from a table when we were doing these together last semester. So I'm going to put it as a table. Either way you do it, it doesn't really matter. What we're doing is I'm looking for the change in my y's over the change in my x's. Rise over run, y's over x's. So I'm going to take my negative 4 and 3 and my 2, 0. I'm just putting them in a table. So I want to figure out how my y's change to go from here to here and how my x's change to go from here to here. Since we're told we're writing a line, all I care about is slope. So I want to know what added to it to make my equation here. So our m is, how do my y's change? Yeah, it subtracts 3. So our m is minus 3 over, what happened to my x's? Plus 6. So this was plus 6. So our slope is negative 3 over 6, or negative 1/2. You can do that from a table like this. If you look the second one in on the important formulas, m equals y2 minus y1 over x2 minus x1. Difference in y's, difference in x's, you get the same exact thing. From here, what we do is we're writing an equation for a line. Equations for line come in that very, very first one on our formula sheet. Y equals mx plus b. Well, I have m, and I have a point. Thanks, sir. So I'm going to plug in the pieces that I have. I'll start with m. Y equals negative 1/2 x plus b. And then I'm going to pick one of my points. And it doesn't matter which one. I'm going to go ahead and do the 2, 0 because that's going to be less work. If we have our x and our y, and one of them 0. I like zeros. Zeros are fun. So I'm going to substitute that in. So y is 0 minus 1/2 times my x of 2 plus b. And we're going to simplify this. 0 is negative 1/2 times 2 is negative 1 plus b. What's our b? 1. So our equation, I'm going to come back and grab this guy and plug in the pieces I have. Y equals our m of negative 1/2 x plus 1. That's how we write an equation for 2 points. Okay? You guys want to toss out one more? Are we okay? What are we doing? 11. Let's look at 11. I'll find it. 10. Oops. Ah, conversions. Unit conversions. So, almost fell off the edge of the desk. It felt like I was gonna. I wasn't, but it felt like I was. So sometimes it helps to think about specific numbers when you're doing this. So if I want to know how many weeks it is, and I know how many days it is. So let's say pretend it was 14 days. How many weeks is that? 2. How did you do that? If it was 14 days and you know that's 2 weeks, what did you do with the 14? Divided by 7. So we took whatever number of days it is and divided it by 7. So the number of days divided by 7 gives us how many weeks? As we did 14 divided by 7 equals 2. So if I have some number of hours and I want to know how many days it is, so I'm going to pick 48. What are we going to do with the number of hours to find out how many days that is? Divide by how many hours in a day? 24. Hours divided by 24 tells us how many days that is. If I wanted to switch that around and go days to hours, I know it's 2 days. How many hours is that going to be? If it was days to hours, what would we do differently? Number of days times 24. Yeah. Okay, so the order is important, and if you do the letter of what they're asking about and think through a specific number, it sometimes makes it easier to do that conversion. Okay? And sometimes you may have to set up more than one. Like years to days you can probably do. Hours to minutes. Oh, no, yeah, those are all probably things you can figure out from here. Okay, hours to years is probably the most complicated one because we don't know how many hours are in a year. But I know how many hours in a day. And we could then do days to years. Okay, so that you could set up. There are 2 minutes left in class. If you're working through this tonight, you got questions, text me, email me, whatever you need to do. Or swing by later today. Tomorrow we're going to do the multiple choice section. Monday you'll have all day to review, but final start, you'll have your 5th period final on Monday. Our final is on the Tuesday. So.
Can I come to take that test?
Yeah. Okay, so let me know if you guys have questions. Have a great rest of your day. Happy Thursday.